everyone, we're going to identify and graph the polar equation r equals 2 plus 4 cosine of theta. This is a Limacon with the inner loop. That's the identification. I'm going to show you the form in a few moments. Right now, let's test for symmetry for our graphs. So we can graph half of the graph and then just use symmetry to graph the other part. The first test is see if it's symmetric to the polar axis, which is the x-axis, by substituting in negative theta for theta. So instead of theta, substituting negative theta. Since cosine's an even function, this is going to be 2 plus, this just goes back to positive. So this means it's even, and since it looks just like our original, they are equivalent. That means our test passes, and it is symmetric to the x-axis or to the polar axis. So this one's good. Let's check our symmetry with respect to the line theta equals pi divided by 2, which is the y-axis. So basically what you were going to do is substitute in our theta now with pi minus theta. So you're going to have r equals 2 plus 4 times cosine of pi minus theta. This has this form here, so let's expand it using our sum and difference formulas. This is going to equal 2 plus 4, and then we're going to get cosine of pi times cosine of theta plus sine of pi times sine of theta. All right, simplifying this, sine of pi is 0, so this just zeroes out. Cosine of pi is negative 1. So I'm going to bring this negative 1 out, and I'm going to get r equals 2 minus 4. That's just negative 1 cosine of theta, which does not equal our original equation, 2 plus 4 cosine of theta. So this test fails. It is not symmetric to the line theta equals pi divided by 2. The last test is testing to see if it's symmetric to the pole. This is going to substitute r with negative r. And this fails because it doesn't look the same. The only time this test is going to pass is if you have a r squared here. Okay, this is a Limacon with an inner loop because it has this form. That means my a is 2, my b is 4. So my b is greater than my a, i.e. my 4 is greater than my 2. Therefore, it's a Limacon with an inner loop. If this number was smaller, say this was 4 and this was 2, then it would be a Limacon without an inner loop. If the numbers were the same, so if these were both 2's, then it would be a cardioid. So we have something that looks like this. All right. By the way, all of this little definitions and tests are on my Facebook page. If you ever need to save a photo copy, you can go there and just save a photo. All right, since it's symmetric to the polar axis, we're going to assign our values of theta to 0 to pi. So we set up a little table here, and we're going to have theta going from 0 to pi. So 0, pi divided by 6, pi divided by 3, pi divided by 2, 2 pi divided by 3, 5 pi divided by 6, and pi. And then we're going to use symmetry to graph. This is just the first half of the graph. Half of the graph. All right. So we're going to find our r value, our output. So if you substitute in 0, we're going to get 6 for r. Pi divided by 6, you're going to get 2 plus 2 square root of 3, which is approximately 5.5. At pi divided by 3, we're going to get 4. At pi divided by 2, we get 2 for r. At 2 pi divided by 3, we get 0. At 5 pi divided by 6, you're going to get 2 minus 2 square root of 3. Now that's approximately negative 1.5. And at pi, we're going to get negative 2. So let's start plotting our points. At 0, our angle is 0. We're going to go out 6. So 1, 2, 3, 4, 5, 6. All right. At pi divided by 6, we're going out 5.5. So 1, 2, 3, 4, 5.5. All right. At pi divided by 3, we're going out 4. 2, 3, 4. At pi divided by 2, we're going out 2. All right. At 2 pi divided by 3, we're at whoops. Got too close here. At 2 pi divided by 3, we're at 0, so it's here. Let's graph what we have so far. So it's going like this. Yeah. Kind of goes out like that. All right. At 5 pi divided by 6, we're at negative 1.5. So we're going opposite this way. So it's going through this way. And at pi, we're at negative 2, which is right here. So it's going this. There's half of the curve. Now we're going to use symmetry with respect to this line here to finish the graph. So I started here, ended here. So now at 4 pi divided by 3, I'm going to my 3's here. I'm going to just kind of make this symmetric right here. And at pi divided by 6, where were we at? Negative 1.5. So this is going to go loop around like this. And come back around. And then at pi divided by 2, it was at 2. So this is going to go to 2. It's going to loop around like this. And then come back around. And you can match things up. At 5 pi over pi divided by 6, it went to 5.5. So this would be 1, 2, 3, 4, 5.5. Should swing out a little bit more than that. All right, so there's your graph. Just match up your symmetry here. Again, we started at 6. So what it should do is it should go something like this. And there's your graph. Thank you. Have a nice day. Bye-bye.